Hello there. Welcome to the Autodesk 2020 Vision Series. I'm Phil Peterson, a senior software architect on the Autodesk Shotgun software team. I'm delighted to be joined today by Jeff Stringer and Michael Nowakowski to talk about advancing and automating scheduling and resource optimization at Leica. That's me. There we go. Michael is the pipeline technical director at Leica, who focuses on scheduling and fabrication workflows. He is interested in the creative applications of computer science to visualization, imaging, and filmmaking. Jeff manages a team of technical directors and software engineers to devise cutting-edge tools and technologies that support the broad range of creative artists at Leica. And he has played a critical behind-the-scenes role in the success of every Leica film. Jeff's past credits include production and technology management roles at Digital Domain and Tippett Studios. We're going to have plenty of time for Q&A at the end of the session. So along the way, if you have questions, please make sure to put them in the Q&A window. So Jeff, to kick things off, can you tell us a bit about Leica?
Sure, thanks, Phil. First, let me say that Michael and I are very excited to be here and to take part in Autodesk Virtual Vision Series 2020. For those of you that don't know, Leica is a feature film animation studio. We're located up in the beautiful Pacific Northwest, not far from Portland, Oregon. We have made 5 original films, starting back in 2009 with Coraline, which is still one of our best-known films. And we followed that up with Paranorman, The Box Trolls, Kubo and the Two Strings, and most recently, Missing Link last year. What's unique about Leica is that we use stop-motion animation to make our films. So this is an old-world craft-based technique, and we fuse that with advanced technologies and visual effects to push the boundaries of what you would think is possible in a stop-motion film. We try to tell big, bold stories, whatever our directors can dream up in this medium. We've been fortunate over the years to have received a lot of recognition for our work. Each of the 5 films has been nominated for an Academy Award. And our most recent film, Missing Link, also received a Golden Globe for Best Animated Feature, in addition to 2 Visual Effects Society Awards and 8 Annie Award nominations. Travis Knight is the CEO and the creative visionary behind Leica. He's also one of our most talented animators. Travis knows this process intimately, and he loves it, and he pushes us to do more with each film than we've done before. So it keeps it fun and keeps it challenging. 2020 is actually our 15th year in business. We're celebrating our anniversary with some films to highlight our work. And I brought one of those, which we can share now. Go ahead and cue up that first video.
Leica is really an extraordinary place. I think the air just crackles with creativity and innovation.
When I toured the Leica studio, I was just amazed at, first of all, the size of it.
We grow in our creative capacity and our artistic ability with every successive film.
It is a real puppet in a real sense.
You feel like you're in this factory of dreamers.
What we do at Leica is to take this style of filmmaking, which is craft-based. It's about artists using their hands to bring something to life. Kinds of stories that we're developing now are unlike anything that we've ever done before.
The movies they make leave you with something very inspiring and heart-filled.
I feel like we're just getting warmed up. We're just getting started.
Thanks, Jeff. Every time I look at Leica's work, I'm just blown away by the complexity and the scale of your whole filmmaking process. Planning and coordinating, every task involved just seems daunting. I've had the great pleasure of collaborating with you guys at Leica on your scheduling and planning approach, over the last year or so. Michael, can you tell us about the new workflow you developed?
Sure. So there's a couple different parts to the new workflow, and we actually have a cool video adapted from some material that we also presented at SIGGRAPH this year. So if we could play that second video, that would be great.
This is a presentation on our new browser-based workflow for scheduling and automated resource leveling. Our new workflow enables a user to quickly iterate on a complex fabrication schedule, using an advanced Gantt tool for data modeling, Shotgun for day-to-day task management, and a new program called Concilium for resource balancing and leveling. These tools turn a time-consuming and error-prone process into a fast, automated procedure that generates an accurate, adjustable, and easy-to-communicate schedule. Creating a Leica film is a massive undertaking. Stop-motion animation requires the creation of thousands of sets, props, puppets, and costumes that must both express the creative language of the film and be able to be rigged and animated in painstaking frame-by-frame detail. Perhaps even more daunting is the challenge of coordinating work between our fabrication groups to ensure all our assets fit into the same world and are delivered to the appropriate stages in time for their moment in the spotlight. A schedule is an essential part of enabling this intricate filmmaking machine. First, it helps us get the right resources for our production and ensure we're hiring an appropriate number of people with the right skills. Second, it provides prioritization for our work. Knowing what is due when and who should be working on what lets us make a movie as efficiently as possible. Third, the schedule is an important communication tool. As our films have grown in complexity and scale, communicating work within and between departments has become more of a challenge. An effective schedule can help departments, and shops within those departments, know how their work integrates with Leica as a whole. At Leica, scheduling starts with a bidding process, where departments estimate the work necessary to create each asset by breaking them down into a list of tasks with durations, resource assignments, and dependencies on other tasks. These task lists are then brought into our production database and leveled to ensure three competing interests are met. 1. Each task is completed in time for other departments to complete their work. 2. Each asset is delivered in time for its scene shoot date. And 3. That no group or person within each department is overloaded with tasks. Balancing these goals is an incredibly difficult and time-consuming job that takes years of experience to master, especially given the complexity of a real production schedule. For example, the puppet schedule on Leica's upcoming film consists of 12,000 tasks spread across 300 assets, and resource leveling requires finding a way to balance the workloads of 60 people with 15 different skill sets. Our previous scheduling solution utilized Microsoft Project to create task templates that express the work plan for various assets. These templates were then combined with custom per-asset durations defined in an Excel spreadsheet, put back into Project to be auto-scheduled, and then finally exported via a custom app to Shotgun, a web-based project management database that offers spreadsheet and Gantt views of tasks. There were some pretty major limitations to this process. First, the round-trip process was cumbersome. Initial bidding often took weeks, and data in Project and Shotgun could easily get out of sync when doing updates. Second, Shotgun also didn't have sufficient resource visualization tools. Users struggled to see what resources were overbooked, and what wouldn't deliver on time. Finally, hand leveling such an enormous dataset is laborious. Every push or pull in the order of tasks to benefit one group tends to come at the expense of every other group, with few easy solutions. Perhaps even worse, the moment a hand-adjusted schedule was completed, anything from daily changes in the shooting schedule to R&D taking longer than expected to story changes could make it obsolete. Without effective tools to evaluate and adjust the schedule to accommodate changes, craftspeople often ended up overworked and assets delivered late, which slowed the pace of shooting and made it harder for downstream departments like rigging, camera, animation, and visual effects to meet their deadlines. The goal of this project was to develop a new scheduling system that would work studio-wide and enable faster iteration, as well as better resource visualization and leveling. We were already heavily invested in tracking, reporting, and distributing schedule information with Shotgun, so we decided to follow a progressive enhancement strategy, building new features and workflows on top of our existing database and UI. We wanted users who were familiar with the Shotgun UI to still be able to use it when it was effective, then switch to our custom tools when they needed extra features like auto-scheduling and leveling. This also minimized scope creep. We weren't trying to reinvent Shotgun, just improve its scheduling features. The first step was building an app that would enable users to capture all the complexities of a real production schedule. Shotgun's built-in data models weren't sufficient for this, so we created a new database schema on top of Shotgun's existing scheduling infrastructure, then customized a third-party Gantt component to be able to edit, auto-schedule, and save task information back to the new schema. With the new Gantt, users can select one or more entities and launch into a custom schedule editor with just the feature set required for editing and syncing tasks directly to our database. All the standard project dependency types are available, as are typical scheduling constraints. With the Gantt component and custom schema in place, users can edit their templates and production schedules in the same application, with full access to auto-scheduling features like dependencies and constraints. Even better, this data is synced directly with our database, so all our existing infrastructure for task assignments, navigation, and reporting is still usable. With the schema and the Gantt app ready for use, it was time to move on to updating the bidding process. We felt our bidding approach, where users define task templates and complexities for assets, was still effective, so we worked to maintain those conceptual models while streamlining the bid process. In our new workflow, users create task templates directly in our database, and then can assign and edit task template and complexity assignments in a new bidding app, which updates production schedules directly. This new bid process is entirely in browser, with all data stored in our custom schema. We now had an effective way to bid and rebid our schedules, but leveling the schedules to balance resource usage was still an error-prone manual process. We wanted a way to generate a schedule that met our fabrication and filming deadlines while ensuring that all of our dependencies were optimized, neither over nor underutilized. We tried some in-house leveling programs on our data, as well as a modern constraint solver, but the size of our larger datasets and the processing time required for brute force leveling made these approaches infeasible. Fortunately, we ended up collaborating with a startup developing a product called Concilium. Concilium allows you to create multiple scenarios of a complex set of tasks, dependencies, constraints, and resource requirements, and then, using a machine learning approach, automatically generate resource-optimized schedules. Concilium enables a user to create different scheduling scenarios where they specify parameters for how many tasks should be assigned to a resource. Once the user has entered their targets and pressed Schedule, Concilium's scheduling engine searches for a way to adjust task start dates for the schedule while still satisfying all constraints and dependencies, so that each resource is as close as possible to its target curve. This process happens relatively quickly. It can take anywhere from a few seconds to a few minutes to find a solution, depending on the size of the schedule. Once a solution is found, the resources and schedule views can be used to visualize the results. Let's take a closer look at each of the options available. The Overview tab is a stream graph showing all the resources together. From this tab, a user can find points of concern, then switch to the Detail and Assign views to take a closer look. The Detail view shows the target resource curves, depicted as a line, along with the actual utilization of the resource in the current Concilium scenario. Loading multiple resource curves at the same time is a nice way to check the trade-offs Concilium has made in its schedule. A production manager is often tasked with making trade-offs between the burden on different resources, and these graphing tools give them a quick way to see the results of their selections. Another useful visualization tool is the Assign tab. From here, a user can see how Consilium has chosen to assign and overlap tasks, and see what assignments will look like when they bring the data back into Shotgun. Lastly, Consilium offers a full Gantt chart representation of its plan, which offers insight into the constraints and dependencies in a user's schedule. Consilium has made a big impact on our scheduling workflow, and it is being used in production at Leica for managing tasks in several departments, most notably as the primary means of scheduling the puppets department. To wrap up this section, I'd like to summarize the key features it offers. First, Consilium is able to consider all the resource groups at once, while still placing higher priority on certain groups, and provide a resource detail view that makes it easy to compare available headcount to workload. Second, Consilium's resource views provide an effective way for users to see trade-offs in weights and curves for different resources, something that's hard to do when manually scheduling. Third, Consilium offers fast schedule iteration. Schedule data is constantly in flux, so being able to adjust and level a schedule in a matter of minutes means that the schedule can respond quickly to changes in shoot schedules or staffing changes. It also enables the user to evaluate how different scenarios might affect their resources without spending days rearranging their schedules. Finally, Consilium is able to assign tasks to specific resources, which enables a user to assign tasks to a class of resource, like a generic costumer, and have the app assign and evenly distribute work between costumers 1 through 5. Here's an example of what Leica calls the one-line schedule. Each task represents a scene in a film, and the goal is to minimize the number of assets required. On the left is a human-leveled schedule, which requires 334 assets to shoot the film over 3.5 years. On the right is a Consilium-leveled schedule with the same start and end dates, which is able to reduce the number of assets required to just 251, a savings of about 83 assets. The human-leveled schedule took weeks of time to build, whereas running it in Consilium took less than a minute. This means we have time to run other scenarios, like a finish the movie a year sooner scenario that uses 308 assets, or a finish the movie 6 months sooner scenario, which uses just 270 assets, a significant labor reduction over the initial human-leveled schedule. Now that you've learned about our tooling, let's run through our scheduling process step by step. The process begins with a bidding phase, where the tasks for a schedule are created. During this phase, task templates are created using our custom Gantt tool, and complexities are assigned using the bid app to create a schedule in Shotgun. Second, the user runs our Shotgun to Consilium tool, selects a configuration and planned start date, presses Submit, and gets back a JSON representation of the schedule formatted for Consilium, as well as a web page that displays a table specifying all the infeasible constraints and a tree representation of all the interactivity dependencies. Third, the user uploads their plan to Consilium and uses the tools there to level their schedule. Fourth, the user downloads their schedule from Consilium and uploads it back to Shotgun. After the initial bidding phase, the schedule enters into production mode, where the film is actively being worked on. In this phase, managers, schedulers, coordinators, and artists all update task assignments, dates, and statuses in Shotgun, just as they used to in our old workflow, and then use Consilium for periodic re-leveling to handle bigger changes. Things like new assets, shoot schedule changes, or unexpected task duration changes. The approach we're using for this process is to have the user select an upcoming section of the schedule to lock in place using a special field in Shotgun called Consilium Locked, then load the schedule into Consilium and have it reflow the unlocked tasks in the schedule around the locked ones. To conclude, the introduction of our scheduling workflow has made a big impact at Leica. Changes are now significantly easier to accommodate, and there is increased confidence in the scheduling process. Filmmaking at Leica happens over a very long time frame, with each film taking several years to complete. So unfortunately, we don't have a full sense of the time or cost savings yet. But results so far have been quite promising, with users able to turn around new bids and resource lists faster than ever before. Thanks for listening.
Thanks, Michael. So, to start off with little questions here, in addition to developing some tools internally, you adopted some new technology for automating task scheduling to optimize the use of resources. Was there a specific aha moment you felt this was going to work, or was it a long period of trial and error?
Well, I think Michael can probably speak to the aha moment of putting this method into practice, but I can speak to the moment when we realized we needed more automation and decided to call Phil. I think Michael's video does a good job of illustrating just how important the asset build schedule is to making the whole film work. They has to fit just right between the design and the stage task, the shoot of the film. And these puppets in particular are engineering marvels. I mean, each one is like unique. Like I said, we're always trying to do something we've never done before. The complexity is just more than the human mind can really get their heads around. And over the years, we worked on mapping that complexity out. And we'd gotten that far so that we felt that the bids were accurate. But the trick was doing quick iterations on them and seeing, what different versions of that schedule could look like if optimized for, the head count. And I guess it was during the get a schedule out fast enough, you guys need to fix it. So we remembered having seen a hallway demonstration at SIGGRAPH 2018 of a tool you were working on that promised to crunch the data, that we were producing in a quick way. And that's when we reached out. And I think it was a bit of a gamble. We didn't know much about how Consilium worked, but we did know that you were trying to solve the problem that we had, which was how to take all this complexity and turn around scenarios quickly. And then, Michael got the job of trying to make that work. You can probably speak to that, Michael.
Yeah.
Does he hear us? Uh-oh, he's muted. I don't hear Michael. Darn. Try again.
Now are we good? Is it working now?
Yes.
There we go.
Yes.
Just in time before I made up an answer for you.
Yeah. There was a bit of trial and error, definitely just trying to stuff our data into Consilium, make it all work, because we just had an initial schedule that was done in Shotgun. And Consilium definitely needed more information. It needed to know more about our schedule than Shotgun knew about it at the time. So there was some data modeling that we had to do there. But then there was definitely a big aha moment of the first time we successfully got a schedule from Consilium back into Shotgun, and we were like, this is going to work. Instead of having to manually, level out these 12,000 tasks, we were able to just press a button and get a schedule round trip back to Shotgun. But I think there was a second big aha moment, which was a couple months later when the shoot schedule for the film that we were working on changed completely. And it was still just the same amount of time to round trip it to Consilium and bring it back to get a brand new schedule that also satisfied the new shoot schedule. Whereas other departments would have had to go back and re-level their whole schedule based around the change in shoot dates. It was really easy for us to do it because we'd spent the upfront time to build in all of these constraints, so that when the shoot dates changed, we were just able to press the same button and get back a new schedule.
Cool. So, you hinted at something, both the talk and I think in Jeff, what you were saying, that it would be great if you could kind of both elaborate on a little. There's the resource leveling itself, but also the time to turn around a new scenario, including the leveling as part of it. What's the potential impact of that on how you plan and schedule shows? And is there a good business case for doing that, this more sort of dynamic revisiting of schedules?
I think there's, so I'll speak a little bit to just like the being able to turn around things quickly, which is, I think there's a lot of advantages there in that rather than kind of being constrained to doing sort of what you've always done scheduling wise, where you just like level based on having roughly the same number of people you might have had on the last show or whatever. Here you're able to see like, cool, I'm going to like run that initial pass where I just do like a gut guess of having roughly the same number of people as the last show. And then there's an easy way for you to visualize and see like, oh, maybe actually one particular group is going to be a big bottleneck on an upcoming show because the costumes are more complex or, a variety of other challenges you might have. And you're able to quickly see like, okay, here's like my initial pass, but it's only another minute to run a schedule where I say, let's double the number of people in that department and see what that does for everybody else schedule-wise, which I think is really cool. The other thing that it lets us do is kind of swap around the order in which we schedule things. So when we're creating this puppet schedule, it's usually predicated on these delivery dates that are created in advance by production. But we're able to turn that on its head and say, okay, but what if the shoot dates for production were based on what works best for puppets? Like, how can we combine those things to make one schedule that works best for everybody without impacting still like the overall shoot time for the show?
Yeah, I can speak a little bit to the business case. I mean, I think there's always a business case for having the absolute best plan possible when you go into production. But to have that, it takes a lot of iteration. And if you want to be honest about the complexity of the work, doing that iteration takes some tools, some smart tools and some automation in order to get it done. What usually happens in film production is that, you go out of the gate with a plan and then, very quickly the plan, of course, has to change. And since it's too complex to change with any degree of accuracy, you don't do it. You instead, you kind of move forward hoping for, sort of a new strategy as you discover it. And if you don't see these things in advance, like something that's going to cause an overage in a department, typically the department will just extend their hours and, people know, they can tell when you're doing the work without a good plan. So it affects morale, it affects costs, it affects everything. It's definitely a problem that needs to be solved.
It seems to me that, in a lot of scheduling workflows, there's a huge amount of implicit knowledge involved. Leveraging automation, and Michael, you already talked about this a bit, often requires a much more explicit model of the world. What are some of the challenges you've faced, trying to do that, and what could be done to make that easier or better?
Yeah, I think there's a big like upfront cost that you pay right now in terms of just modeling the data completely so that Concilium or any auto scheduling engine can work with it. Whereas by default, I think schedulers and production managers tend to have a lot of implicit knowledge that they use to say like, oh, it's okay if those things overlap just a little bit, or it's okay, but only in this specific case, or only if it's assigned to this specific person. And the computer, of course, doesn't know those things. There's no way for a computer to reasonably know those things, I don't think. So figuring out how to work with schedulers and production managers over the last year to like make something that is explicit and still fits what they're trying to do has been a bit of a challenge. Some of that is just like figuring out what the actual constraints are between builds, and some of it is, figuring out how we can build in some dependencies, like dependencies between tasks, for example, where they're like, these can actually overlap by 25%, whereas initially they'd gone in and said, these absolutely are finished to start. They can't overlap at all. So figuring out those relationships was a challenge. But I'm really hopeful that that pays off over like months and years, and kind of the same way that like writing tests for your code does. Like upfront, definitely takes more time to start with, but in the long term, you're really glad that you did it because it means that you actually have a consistent, workable schedule for the foreseeable future. I think one of the things that could be done to make it a lot easier is, I know this is a big problem that we've had, in particular, like with the Puppet schedule, where there were just like a lot of constraints that we were initially applying that were totally infeasible. They just didn't work. Like we'd have a case where it'd be like, well, we want to build a Puppet initially, and we're going to use that as like the skeleton, the framework for building a couple downstream puppets. But it's hard to remember, keep track of all those different dependencies between builds when you're creating a schedule manually. And so what this did for us was force us to reckon with these dependencies that we had kind of implicitly defined by explicitly defining them, and making us realize that if we want to make a build that's downstream depend on the skeleton of an upstream build, we're going to need to extend the amount of time that we have to build that puppet. Yeah.
Yeah, I would just add that I think the best producers and production managers that we've worked with, they've all got a really well-developed gut instinct for what it's going to take to get a movie made. And that's typically what you rely on. It's a super valuable tool that's developed usually over a lot of productions, but it's difficult to teach it, and it's difficult to scale, with only if you don't have a production manager in every group with that kind of gut instinct. And so what we've tried to do is map out that implicit knowledge into explicit constraints and dependencies. And that's a commitment up front, and not everybody's willing to do it. But I think where we've proven it out is that it has shown that you can do more than what you could manage manually. You get to run different scenarios. And basically the trick is once you've got all this data, not relying on it completely to give you all the answers. I think you still need those gut instincts. They still play an important role. And, what we're hoping is that having all this be transparent and seeing the underlying data behind these decisions, it'll help the PMs develop those instincts, the production managers, and also to modify them. So, but yeah, good resistance.
Yeah. So we're going to start taking some questions from the audience in just a minute. So if you have questions and you haven't entered them in the window, please do. But before we do that, just one more for both of you. What's next? Like, how do you see scheduling and planning for production evolving? And where would you like to see technology go to help with that? The pie in the sky view, and I'm not promising anything. I'm sure no one else is.
I still think there's a long way to go visualization-wise. I think we're just starting to figure out what good visualizations are, and they're going to be different for different groups and different problems. But visualization tools are becoming so much more powerful. Like the amount that you can visualize on a screen, especially like a high DPI screen, means you can get a lot more insight into your data all at once, which I think is great. Lets you slice and dice your data in a lot of different ways. So I'm hopeful that there's a lot more work now that we've got the data set to visualize it in different ways to solve particular problems. I think also tying into actuals is a big thing. That's something that historically Leica has not done necessarily the best job of. We create this plan, but we don't always have a good reckoning with how we did at the end of a show meeting up with the plan. And I think feeding past data into future planning would make a big difference. We'd make much better predictions about the future. So yeah, I think those two things. And I guess also along with this visualization component, finding ways to communicate these more complex schedules to staff in a way that makes sense to them and doesn't feel overwhelming. Because if you inundate someone up front with okay, you're going to have to do these 200 tasks over the course of the next 3 years, that's just too much complexity for someone to deal with up front. So finding ways to slice and dice that information by days and by weeks into something that feels manageable and comprehensible to people is really important.
Yeah, I can tell you that our goals for next year with this system is, a more complete integration with our human resource information systems and our finance systems, so that we can take the data for the production plan and generate things like cost to complete reports and scenarios that translate to staffing or recruiting calendars or space plans. There's so many different elements to running a studio that have to adjust with the production schedule. And we feel like this is the data source that could help drive some of those things. So that's a big part of what we're going to try to do. And to Michael's point about the actuals, I mean, this is kind of pie in the sky, but I think it's realistic, especially with what we've been doing with machine learning. If we can develop a real set of actuals, that shows what really happens to build a puppet, not what we plan and think and project is going to happen, then you could maybe invert this process to go from the sort of the intelligent designer role of somebody just sort of mapping out all these dependencies to seeing what really takes place and using that to inform your most optimal schedules. Because I'm convinced that things are happening out there to generate these assets that we're not really even seeing yet.
Yeah, I can't imagine there wouldn't be. So that was great, guys. So a few questions. I've been teeing a few up here, and please, if you have more, go ahead and enter them. One was, I think, I'll start off with a bit of explanation. Someone asked, can you explain again what leveling out means and explain the graphs shown? So I'll take that one just to launch off. So what's being referred to here as leveling and resource leveling is if you have, say, a group of resources, for, in this case, the puppets, let's say, or in general CG, a modeler, our modeling department, and you have a number of modeling tasks, what you may want to do is distribute those tasks over time, subject to all the dependencies they need, so that you're not incurring a lot of overhead. There's not a lot of peaks and valleys in the workload across, say, an entire department, and across multiple departments, and across a whole company. So that's really the process of leveling, moving tasks around in time that still meet all your requirements, but keep your usage and requirements for resources pretty level. So that's really, and the graphs shown was part of that, is the one that I believe was shown a lot, looked like a stream graph representation. That's really just showing how level each type of resource is over time. So it's a kind of a way of showing the flow of how many people or how many tasks are happening at any given time. So hopefully that explains that one. Let's see, kind of moving on. This one I'll let you answer, Michael. I think this is probably most directed to you, is how are you dealing with partial allocations of tasks to users? I.e., a user should be spending 25% of time in a day on a task.
So yeah, we actually added an allocation field onto tasks that we use in two different ways. It's basically a place where a scheduler can define a head count for a given task and say, like, hey, this is going to take, oh dear, this is turned, so I keep going off the screen. There we go, that's better. It's inverted, it's very confusing.
Yeah.
Disappearing. So what we did was we defined a head count field on the tasks that just says, basically you can enter like anywhere, you enter any float onto it and say, like, this is going to be 50% of somebody's time, or this is going to be, 200% of somebody's time if you're assigning multiple people to it. And what we're planning to do down the road to make that even a little more granular, because some schedulers have chafed against it for not being complex enough, is actually making it so that when you assign resources to a task, you can define a relationship, a head count on the link between the task and the resource. So you could say that it's 50% of some resource's time, but 75% of another resource's time, and 100% of a third resource's time. That's where we're headed with it. But right now it's just a simple float field on tasks, and that's gotten us pretty far.
Great. Another one, are you guys keeping, the question is, are you guys keeping multiple groups of task scenarios inside the same project?
We sure are. We actually ended up developing a system that lets us make copies of a production schedule into like a planning scenario setting. And you can have as many planning scenarios as you want. There is a bit of a burden to like copy them back and forth and just keep the planning scenarios up to date with the production scenarios and making sure that you're filtering those tasks out of all the views, where of course you don't want like artists or anybody to see a bunch of planning scenario data that isn't relevant to them. So there's a bit of work there just to make sure you're filtering those tasks out of the right views. But Shotgun is powerful enough to hold thousands and hundreds of thousands of tasks.
We've proven that.
Yes. And everyone loves to look at those Gantt charts that are that big too. So another question, which looks like this one's probably for me. What kind of data did you use to train the machine learning model for Concilium? Was it based on previous production schedule data? So I'm going to answer this one in two parts, and it relates to, I think, a couple of things that Jeff and Michael were talking about, sort of the future of scheduling. So if you look at the problem of scheduling in general, it almost falls into two pieces. One is estimation of effort, which is how much effort and what kind of resources you're going to need to do something or you expect to do. And then there's, given those estimation of effort and all of the data around dependencies and timing constraints, is how do you create a schedule that is reasonably optimal in that sense in terms of resources or other optimality conditions based on those estimates. So what you've seen today is based on that second part. It's about scheduling. So given estimates of what you need to do and a data model around that, how to best schedule that. The interesting part, sort of the future, is how do you also extend this idea to estimation? So to answer the first part of the question, it's a little bit roundabout, but hopefully it helps explain it. In this training set for creating a schedule, there really is no canonical training set for how to push and pull a schedule around. So in this particular case, the model is actually synthesized on the fly, unique to each schedule. So each time it does it, it's actually synthesizing from scratch based on no prior data set. So parameter based. So hopefully that answers that question without going into a machine learning and algorithm chat today. So another one here. Let's see how we're doing for time. I'm interested in any differences you have found or expect in scheduling physical versus CG tasks. Do you use this scheduling methodology in production for both physical and CG tasks? Do you find to expect any differences in the approach to scheduling these two types of tasks?
We haven't gotten to the point of scheduling much like the FX work or like any of the CG stuff that comes at the tail end of our pipeline. But I think there are some fundamental differences in terms of how you schedule those things. And some of them aren't fully accounted for yet in Concilium. Like, for example, with the scene stuff, we run into the situation where like we only have a finite number of units and we can only put, it is actually work to take down a set and put it back up again. So we really want to keep, set utilization as tight as possible. We don't want to have to build a set, put it away, put another set on that unit, take that down and put back up the first set again. That's something that's unique to practical assets. It's not a problem you're going to have in CG because it's no work to open and close a Maya scene, really. So that's just like one of those fundamental differences where it really just comes down to modeling the data slightly differently, and then trying to find ways inside of the scheduling engine to account for differences in practical versus CG stuff. But I would say the CG stuff is a little bit easier because you don't run into as many of those like startup and teardown costs, or as many problems with like once you've built an asset in practical land, you still only have one of that asset that can be in a place at any one time. Whereas in CG land, once you build an asset, you can kind of use it as many times as you want on downstream applications.
Cool. So let's move on. Another question. Is Concilium available to others, or is this still proprietary to Leica? So I guess I need to answer that one, or I will answer that one. So Concilium has recently been acquired by Autodesk, and I've joined Autodesk as well. So look out for the future shotgun roadmap for announcements in the future. We're currently working on integrating and developing this technology as part of the shotgun ecosystem. So stay tuned. If you have more questions, perhaps if you are a shotgun customer already, please contact your shotgun rep, or definitely ask questions on the shotgun forum at community.shotgunsoftware.com. So there we go with that one. But this one follows on, I think, pretty well from that is, one, just a compliment. I think Leica's films have always been beautiful from one of the audience members. Do you have any good pointers for a studio that would like to adopt these tools? What is next from your perspective to make this even better?
Yeah, that's a good one. I
don't know.
I think the first step has to be, the data modeling with the production managers. Map it out. You got to map out what it takes to do the work. Because that's step one is, define the work required to do it, and then you get to the point where you can then find the optimal, way to level that work and do it for the fewest resources you need to hire. But you can't get started until you've mapped things out. So if you haven't spent some time on that, start there. And that basically comes down to templates, like task templates, like what are the different steps and how concurrent are they? What are they dependent on? What are the constraints? You gotta know the steps. You gotta know their dependencies and constraints.
And I think there also has to be appetite if you're going to embrace that at a studio and spin up a new workflow like this, is that people have to be aware. You need to make some expectations clear up front that parameterizing a schedule will require a different kind of thinking than just kind of on-the-fly scheduling or scheduling manually. So that's something to consider. People need to be prepared to put in that upfront investment to get the payoff down the line.
Our team was definitely motivated by the just sheer complexity of these asset schedules, and the need to be transparent about the resource requests. You can't hire 10 people if you can't demonstrate why you need them, and that's usually a big motivator for production managers, to give them data to back up what they're asking for.
Well, I think we're getting pretty close to time to wrap up here. But before we close off, I have to do one thing that's important, and you have to listen to me read this in my sonorous voice. It's a safe harbor statement. So during this presentation, we may have made statements, or we may make statements regarding planned or future development efforts for existing or new products and services. These statements are not intended to be a promise or guarantee a future delivery of products, services, or features, but merely reflect our current plans, which may change. Purchasing decisions should not be made based on reliance on these statements, and Autodesk assumes no obligation to update these forward-looking statements to reflect events that occur or circumstances that exist or change after the date on which they were made. Whew. Hope everyone got that and took notes. So just kind of in closing, I want to thank everyone for attending this virtual series session. And once more, thank you very much, Jeff and Michael, for joining me and for the collaboration we've had over the last couple of years, and to share your new workflow with everyone. And I think that's it. And cheers.
Thank you, Phil.
Thanks, everybody.